Finally, here is the last part for this chapter, handling exceptions. Till now, we have learned about exceptions, built-in exceptions, throwing exceptions, and also have tried few programs on it. So as we know, each and every exception has to be handled by the programmer to avoid our program from crashing. The process of handling exceptions include writing additional code in a program to give proper messages or instructions to the user on encountering an exception. We will cover four subtopics in this video, which are need for exception handling, process of handling exception, catching exceptions, try except else clause. Firstly, need for exception handling. So, if you are wise enough, you might have understood the need and advantages of exception handling process. As stated on your screen, exception handling is being used not only in Python programming but in most programming languages like C++, Java, JavaScript, C, etc. It is a very useful technique to catch runtime errors and handle them to provide smooth flow in our code. Some important points regarding handling exceptions are: first point, Python categorizes exceptions into distinct types so that specific exception handler can be created for each type. We have already discussed few types of built-in exceptions in our previous video. Second point, the segment of code where there is any possibility of error or exception is placed inside one block. The code to be executed in case the exception has occurred is placed inside another block. We will, uh, we will discuss about these blocks in the further segment of this video. Third point is the compiler or interpreter keeps track of the exact position where the error has occurred, and this is displayed in the traceback stack. Fourth one is exception handling can be done for both user-defined and built-in exceptions. So guys, here let us take a glance over the diagram which is provided in our textbook, which represents us about the process of handling exception. So here, as we are given, a step one is an error encountered in a method. So if this happens, the step two is it creates an exception object, and in the next step they are saying that the exception is raised. So in the step one, they are saying that when an error occurs, Python creates an object called the exception object. This object contains information about the error like its type, file name, and position in the program where the error has occurred. And in the step 2 and step 3, they are saying that it is known as throwing exception. So this process is known as throwing exception. So the object is handed over to the runtime system so that it can find an appropriate code to handle this particular exception. This process of creating an exception object and handing it over to the runtime system is called throwing an exception. In the next stage here, which is our step 4, it is saying that the runtime system searches for exception handler in the current method. So the runtime system searches the entire program for a block of code which is known as exception handler that can handle the raised exception. So here there are two situations which can occur. The first situation is if the exception handler is found, it simply executes the code and the program is continuously running. But in the other case, if the exception handler is not found, then it is said that here searches for methods in call stack in a reverse sequence, forwarding the exception. So if the method in which the error has occurred and the exception has been raised is not found, then it searches the method from which this method here means in which the exception was raised, was actually called. And this entire list of methods is known as call stack. If again this is not found, then the program gets terminated. So the process of executing a suitable handler is known as catching the exception. Let us now read about catching exceptions. An exception is said to be caught when a code that is designed to handle a particular exception is executed. We use mainly two blocks to catch and handle our exception, which are try block and except block. In the try block, we write our regular program in which an error might occur in future, and inside except block, we write the code for handling an exception if it occurs. While executing the program, if an exception is encountered, further execution of the code inside the try block is stopped and the control is transferred to the except block. Let us see the syntax of try except clause. The syntax is as follows. We use the keyword try, we put a colon, and in the next line, we start writing the program statements where exceptions might occur. And in the next line, we write except, and in front of it, after a space, we write the name of the exception which might be raised. And remember, this is optional. And inside this block, we write the code for exception handling if the exception error is encountered. Let us learn about all the different types of ways we can handle our exception. One of the way to use our except clause is using multiple except clauses. Sometimes a single piece of code might be suspected to have more than one type of error. For handling such situations, we can have multiple except blocks for a single try block. When an exception is raised, a search for the matching except block is made till it is handled. If no match is found, then the program terminates. So, if an exception is raised for which no handler is created by the programmer, then such an exception can be handled by adding an except clause without specifying any exception. So, it is not actually important or mandatory to write the exception name after writing the except keyword, and it is not limited for us to handle only one exception at a time. Try except else clause. So we can put an optional else clause along with the try except clause. So this runs similar to our if else statement. So here an except block will be executed only if some exception is raised in the try block, as we all know. But if there is no error, then none of the except blocks will be executed, and in this case, the statements inside the else clause will be executed. So now let us now see few programs using the recently learned try, except, and else clauses. Above, here you can see the syntax of try and except statements. Here, now we are trying to execute the program 1.2, which is given in our textbook. It's a very simple program which consists of a try statement and a except statement, and this is try block and this is except block. Here in the try block, we have simply tried dividing two numbers where one number will be assigned to the value of 50. The second number will be asked by the user to input, and then we will divide those numbers and print it. And if the division is successful, we will print the message division successful. Or if the user has entered a 0, then this except block of code will be executed with the 0 division error, and here we will get the message denominator cannot be 0. So let us try this thing. So if the user enters an correct input like 2, we will get that division successful and also the result. But in the other case, if the user hits 0, we will get a message which will say denominator cannot be 0, and remember, this part of code was not executed. Let us now consider the program 1.3. This is also similar to our program 1.2, but the only difference here is we are using multiple except clause, which are the first one is zero division error and second one is value error. So in this program, as per the code before, we were only able to catch the zero division error. But now code through this block of code, now we can also catch hold of value errors. So now let us imagine if the user has entered the input in terms of a string, we will get the message showing incorrect value. Let us now consider our program 1.4. So here, what we are doing is the developer himself doesn't know what kind of exception will be occurred. So he simply writes the keyword except instead of he doesn't write the name of the exception. In these terms, if any type of exception will occur, always this code will be executed, but only if an value error is occurred, this part of code will be executed. So here, if I try to change the value, here I will get an incorrect value message. But if I try to divide it by 0, and remember, I don't have any code here to handle zero division error, but I have a general except statement. So here I get the message which shows some error occurred without stating that it is a zero division error or something else. In a program 1.5, here we are using else clause. Here we are using else statement. So here let us try to know the use case of this thing. So first the try blocks gets executed, and if an exception is raised in this try block, according to what type of the exception is raised, these two except block will be executed. But if any exception is not occurred, or if the try block ran successfully correct, then only this else statement will be executed and the message division successful will be displayed. So let us try this. Let us suppose that the user hits an input with correct value and he doesn't hit 0. Here I get the result along with the message division successful. So the last one of this chapter here is finally clause. We have already learned about try, except, and else blocks. Now this is the last type of a block which we will use in handling exceptions. So the try statement in Python can also have an optional finally clause. The statements inside the finally block are always executed regardless of whether an exception has occurred in the try block or not. If we used our finally clause, it should always be placed at the end of the try clause after all except blocks and else blocks are placed. So guys, coming to program 1.6, here we are using finally clause. So as we just learned, the statements inside the finally block are always executed regardless of whether the exception has occurred in the try block or no. So let us suppose that the user enters an correct input. First of all, we will get the result, and again, and then we will get the division successful message which comes from our else statement, and lastly we will get our thank you message from finally clause. Let us try giving the input as 0. So here we will get the message called some error occurred, but with the same thing we will also get the message of thank you also if an exception has already occurred. So the last topic here is recovering and continuing with finally clause. So if an error has been detected in the try block and the exception has been thrown, the appropriate except block will be executed to handle the error. But in other case, if the exception is not handled by any of the except clauses, then it is re-raised after the execution of finally block. After execution of finally block, Python transfers the control to a previously entered try or the next higher level default exception handler. Execution of the finally clause does not terminate the exception. So guys, let us now learn about the last program in this lesson, which is program 1.7, which tells us about recovering through finally clause. So if an error is detected in the try block and the exception has been thrown, the appropriate except block will be executed to handle the error. But if the exception is not handled by any of the except clauses, then it is re-raised after the exception of finally block. So here, as you can see, I don't have any exception handler for handling zero division error. So let us assume that a zero division error actually occurs. So at this time, first of all, the finally clause will be executed and it will say thank you, but later on, an exception will be raised, creating this disgusting message. So guys, here is a small basic topic which is not given in our textbook actually, but I'm trying to explain this to you. This is known as camel casing. So camel case is a writing format that capitalizes the first letter of each word in a phrase. It is the practice of writing phrases without space or punctuation and with capitalized words. So, as we have seen many of the time, when we try to use two words, we place a underscore or a hyphen in between them. But in the programming world, we use this term called camel casing, and this is type of a format which is a writing format. So, as you can see two examples here. Here I have written my name where N is capital and my is a different word, name is a different word, and I have joined them without any spaces only by capitalizing the first letter of the next word. So here my name is a camel cased word and can be used as a variable. And the next example, we can see richest man in the world, where M, I, T, and W are capitalized as they signify separate words. So this is the camel case version of you can see here richest space man space in space the and space world. So thank you guys. We have finally completed with our first chapter. I request you to always understand the logic behind every program rather than just copying it. Thank you one and all. Keep programming.